What's up, guys? Rex again here with TorchPrep. I'm back at it with math questions from the Red Book. I'm in test 2 on problem number 50. So what I want you to do is go ahead and pause the video. Go to the Red Book, test 2, problem 50, read the question, press play on this video when you're ready. Okay, excellent. So problem 50, we're deep in the test, and we found a pretty hard one here, didn't we? This is the kind of question I would definitely say, at the amount of information it's giving you here, it's a little dense. On top of the fact, you really have to know all of your terminology in geometry well to get through this thing. I think for a lot of you who are not comfortable with all the diction, all the terminology of geometry, this is something I would skip during the survey, spend a little bit more time on in the work portion. Let's work through it right now, step by step. So, they've given you this figure. Here, it is a set of lines forming triangles between 6 different points. Now, with the information they give you in the paragraph preceding the figure and in the figure, they ask you between 5 statements which of these is not justifiable with the given information. So, let's go over what that information was. They told us that line, I know my lines aren't perfect, but in the book, A, C, F, and D are all collinear. Linear means line, like co-worker, right? They're all on the same line. Also, B, C, and E are all collinear as well. Now, the other information they give us is that there are 3 right angles represented here. A, between lines BA and AC, that is a right angle. E, from CE to ED, that is a right angle. And F, from EF to FD, is also a right angle. So, 2 sets of points that are collinear, and 3 right angles represented. With this information, let's go through the 5 options and see if we can justify each of these. The one that is not justifiable with the information is the one that we will choose as our answer. Which one is not justifiable? So, here we go. The first one is letter F. It asks, can AB, that line, be parallel with EF? Let's take a look. A, B, right here, and E, F. Now, this one is, these 2 lines are parallel, and here's how we know. We have our major line here, ECFD, and we have AB and FE. We know that both of those lines are perpendicular to this line. How do we know that? Because they are both angled, labeled on the graph for us at a 90-degree angle. These 2 lines are formed at the intersection of points A and F, and we are told both of those are at 90 degrees. And since they're both perpendicular to the same line, both these lines, A, B, and E, F, are parallel to each other. So that means F is justifiable with the given information. That's not the correct answer. Let's keep going. Now we have D. Is the line DE, is that perpendicular to line BE? Very similar process here. We already have that BCE that those line points are all collinear. At the intersection of E, another line forms from ED. Is ED perpendicular, kind of the way AB is perpendicular to this long line? Is this perpendicular to BCE? From our definition from the last one, we know that it is because it is at a right angle at point E over the angle CED. So we know that, yes, DE is perpendicular to BCE. Next, we have H is asking us, is the angle of ABC congruent to EFC? Is that right? Sorry, I knew that looked wrong. Actually, it's ACB congruent to ECF. Yeah, that's what that should be. So ECF, ACB. Is this angle here congruent to this angle here? Interesting question, huh? So what we know is we have a straight line going through the point C from A all the way to D, and a straight line here, BCE. Remember, C is really the intersection of those two lines in which all the points are collinear on one of those 2 lines, okay? And if you know our rules of angles, we know that circling around that's a terrible circle, but circling around C would be 360 degrees. And the way we can measure between these 2 points is when a line is bisected by another line, the opposing angles are going to be the same measurement. So these 2 wide angles outside of the triangles will be the same angle, and the 2 inside. So yes, we can say that angle ACB and angle ECF are both congruent to one another. We know that H is correct. Now J, asking us about similar triangles. Is the triangle BAC similar to EFC? Now, again, we have to go back to our definition of similar. Do they have the same angles inside the triangle? Is what we're looking for here. Well, we've already said for sure that they do share this angle together. They both are touching at the same points. We know they share one angle. Also, we know they share another angle. So if EF down here, imagine for a second that this is one triangle and this is another. Okay, so CFE is a triangle, DFE is another triangle. This one, CFE, is the one we're looking at. Is it similar to BAC? They both share this angle here. Now, at A we have a right angle. I also know at F we're going to have another right angle. Because on either side of F, either in this triangle or in that, will be right. So we both know both triangles have a right angle and a congruent angle. That means the third angle must also be congruent. Let's just throw some numbers in to make this make a little bit more sense. Let's pretend that C on both sides is 50 degrees. 50 degrees on both sides, and then they have 90 degrees at those points there. And if I know how, the angle inside a triangle is always 180, so take 180 minus 90 minus 50, I know the final angle in both of these has to be the same. Now I'm just using these numbers, they're easily divided by 10. I'm using them as an example. But that quickly shows me that these are 2 similar triangles. So J is also justifiable. Now that means, of course, K is our correct answer. But let's look at what it's asking and show why the last option is not justifiable with the given information. Let's dive in. So CE, this line segment here on this triangle, is it congruent to ED? Let's check it out. I think the easiest way to do this is when we have proven angles that are the same, I continue to fill in all the angles I could between these 3 triangles. So if I look at this one right here, I have 90, 50, and 40. And on EFD, I have 90. And how am I going to find the angle for D and the angle for DEF? Well, up here at E, I know the full angle from CED is 90. I've bisected it and given it an appropriate number here. I can fill in the rest of that on this side. I know that 90 minus 40 has to equal 50. So now just looking at this smaller triangle, EFD, if I have a degree of 50, 90, what is my final angle down here? It's going to be another angle of 40 degrees, isn't it? So I have now, by using just a random number as an example, I have mapped out which angles are going to be congruent to each other. Now, this question is asking us, are these 2 sides of this triangle, are they the same? Basically, is this an isosceles triangle? Is this angle inside the same as this angle inside? 2 sides that are similar. Well, we've proven right here that no. Based on the information we can justify, this side will be a different length than this because we can see that their angles do not correspond. By taking it one step at a time, knowing the definitions of an isosceles triangle and a similar triangle, we know that K cannot be the correct answer. So this is something that's going to take you a little bit of time A little bit of review of words like parallel, perpendicular, congruent, and similar. But this is all stuff you've worked with before, and if you take some time in the work portion of the test, you can get it done. Great job.